Hey guys, so this is my DQ1 here. Today we're going to talk about the hypothesis testing for paired data, multiple population means, and variance comparisons. We're going to talk about common assumptions and practical considerations using Python. So hypothesis testing is a rigorous method that rests on certain assumptions. And some of those assumptions are the differences between paired observations should be normally distributed. Observations must be independent and populations should be normally distributed, and variances across groups should be equal to validate ANOVA results. And then both samples compared in an F test, these are the assumptions that I decided to use, should come from normally distributed populations with equal variances. So then moving on from that, if we, ignore these assumptions, we can skew our data, and non-normal distributions or unequal variances can lead to over or estimating or underestimating the significance of our findings. So it just might lead us in the wrong direction if we ignore hypothesis testing and assumptions. So real world data, right, is messy and there's outliers, and because this is real life, nothing is that simple. So that's why we have these tests. So let's go ahead and move into this Python. Here you can see where I have my data set and kind of a translation in my notes right here because the data is kind of weird. But we're just looking at the height and weight and age and gender. So here I have to translate it from age in days to age in years. But anyway, so here we're looking at, or I'm using a lot of the SciPy data sets. We've got SciPy stats here, and then we've got a whole bunch more down here. I also use tests like Levene's and Bartlett's. As you can see here, I created a wrapper function as the professor kind of suggested in the discussion board. So it sorts out the test type for us so that we can kind of see, the different, what data is going to go with which test, basically. So if the test type is paired, do this thing. If it's ANOVA, do this thing. And then equal variance, do this thing. So looking at all of that, we can come down here and we can see all of our test results. You guys can read this later. It's kind of long. But basically, there's a very significant, oh my gosh, what's it called? There's significant differences among the mean values of the height and weight between males and females. And we absolutely knew that already, but there you go. There it is. Especially when we add in age, it gets even more significant. So the results from these tests indicate a strong statistical evidence against the null hypothesis in each case. For the paired t-test and ANOVA, the null hypothesis posits no difference in means, while the variance tests suggest equal variances. The p-values of 0 across all of these rejects the null hypothesis, indicating significant differences between the means and variances among the variables tested, which, again, logically, we already know because, males and females are generally different sizes across different ages, and it's just a thing. But please remember, it's important that these tests provide evidence of statistical significance and that it does not imply causation. Further analysis would be needed. So here are my sources. Y'all have a good night.